Hi students, this is lesson U1A01. Hopefully by the end of the period, or by the end of the video, you should be able to say I can apply segment and angle addition postulate to algebraic geometry problems. Alright, so let's get to it. Okay, so I want to start off by describing just these are like fundamental ideas, okay? And you are going to be using it implicitly. And what I mean by that is you're not even going to think about this, okay, as you are doing the problems, but these are just things that needs to be said. So I'm going to say it, and once we say it, okay, we will have this like common ground of understanding, and pretty much we'll never like talk about it again, okay? But we do need to establish these facts. And that is, a point is a location and has no size. So a point, okay, which is this guy right here, okay, has no dimension. So when we talk about a point, okay, there's no width, there's no height, okay, but we can talk about the location of where that point is, okay, and it can be described on a grid, okay, it could be described relative to some things, okay, but there's no size to a point. Next is a line is an infinite number of points on a straight path that extends indefinitely in two directions. So this guy right here, okay, is an example of a line, okay? There are infinite number of points that are on this line, and it extends forever. A line will never stop. If you're thinking like, well, how can a line never stop? Well, that's because you're thinking of a line segment. Okay, a line segment does have two endpoints. Okay, a plane is an infinite number of points and lines on a flat surface that extends indefinitely and has no thickness. So just like with a dot, okay, there's no dimension, there's no height, there's no width, there's no anything except for describing a location. For a line, okay, there's no thickness of the line. There's only, well, actually, there's when we talk about line segment, okay, we can talk about the length of the line, but if we talk about just a regular line, there's no dimension, there's no thickness of that line. When we talk about a plane, same thing could be said. There is no such thing as a thickness of a plane. It is just a surface, okay, and it extends horizontally. Well, it extends in two different directions. All right, let's move on to the next. All right, so here we are. We have a line segment. So 2 points form a line segment. If we have 2 points, okay, plotted somewhere, okay, and connect those 2 dots, then we end up with a line segment. And again, there is still an infinite number of points between A and B that form that line segment. And again, there's no dimension other than the length of the line. There's no thickness to that line. A ray is a line with one starting point that extends indefinitely. So we have a starting point, and then it goes on in one direction. And finally, 2 rays with the same endpoint can form a straight line, which is what we have here. And then lastly, 2 rays with the same endpoint can form an angle. So I have 2 rays right now. They have a common endpoint. They can form an angle. 2 rays that are on the same line segment, okay, they can form a line. All right, this right here is the bread and butter of the lesson. You will need to use this, and we will actually be using this idea all throughout the year from now until June, okay? This concept here is embedded in almost every single problem that we will ever use, okay, or that we will ever go over. So the first concept here is the segment addition postulate. And what is the segment addition postulate? Well, the segment addition postulate simply states that if I have a segment AB and I have a segment BC and they happen to be on the same line, then the overall length will be the combination of those 2 segments. So if I have AB plus BC, guess what we're going to end up with? We're going to end up with AC. That's the segment addition postulate. Simple enough, isn't it? All right. The next is we have an angle addition postulate. So here I have angle A, B, C. So that's this angle here. Plus angle C, BD, which is this angle there, I'm going to end up with this overall angle. This overall angle, okay, is going to be angle ABD, which is what I have written down here. So again, angle ABC plus angle CBD will equal to the overall angle ABD. So we have two different postulates, an angle addition postulate and the segment addition postulate. So some things that needs to be said about some of the notation, okay, common notations. So if, pause the screen for a moment, and just to make a note of this for yourself, okay. Take a screenshot of this, make a note of this for yourself, okay, and write this stuff down. If you notice here, okay, I have these tick marks, okay, on segment AB and segment MN. What those tick marks imply is that those segments are going to be the same length. WX, okay, which has two tick marks, will be the same length as segment PQ. So those two segments are the same, okay? So again, the segments in blue are the same as the segments in green. All right? So again, the same number of tick marks shows congruent segments or equal lengths, okay? And there's this vocabulary word. If you're wondering what that word congruent means, I will explain that in a moment. But for the time being, okay, know that they have the same length. The lines in blue is the same as the line in green. And I'm going to explain what congruent means in the next slide. So we can talk about lengths. We can also talk about angles. So you see here we have these little markings, okay, these angle markings here, which I'm calling the arc marks, okay? So these arc marks or these tick marks, okay, for the angles, if we have the same number, okay, of those markings, then we will have, again, the same angle measures. So again, the angles that are in green are going to be the same, and the angles that are in blue are going to be the same, okay? They are going to be, again, what's called congruent. So two things that are congruent, okay, or two angles that are congruent, or two line segments that are congruent, okay, they are going to have the same value. They are going to have the same length. They're going to have the same angle measures. Which brings me to this idea, okay, what exactly is congruence, okay, versus equality? Congruence. So congruence implies if two objects are congruent, then what that means is the two objects can be superimposed onto one another, okay? So again, if two objects are indeed congruent, then the two objects can be superimposed onto one another. So this idea of superimposition, okay, what does it mean to superimpose something? To superimpose something, it means to place one directly on top of another. So for example, if I have a triangle, and if I have another triangle, which is the same exact triangle here, if I were to superimpose this, I place this one on top of the other, what do you expect will happen? We're going to see just a single triangle. All the points will line up. All the angles will line up. All the lines will be on top of one another. This is what we call congruent. Notice this idea of congruence, okay? We do not talk about values at all. We do not talk about the lengths. We do not talk about the angles, okay? We just know that every aspect of these two objects are going to be the same, okay? That's what it means to be congruent. Which brings me to the second idea here, which is equality, okay? So what does it mean for two things to be equal? What does it mean for two objects to be equal? Well, when we think of equality, we think of the value, okay? So two objects may have equal lengths, they may have equal angle measures, or they may have equal sizes, okay? Which is different from this idea of congruence, because we can talk about why are these things inherently values and not objects? Well, when we talk about a length, okay, we're talking about a foot, a yard, a mile, okay, a kilometer, okay. These are actual values. Yes, I recognize that, these are talking about physical things, okay, but they are also talking, we're putting a value to that physical thing, which is very, very, very subtle, and there's some differences there, okay, but I do feel that there is a need to talk about that difference, okay. We can talk about the angles, okay. The two angles can have the same angle measures, okay. So we need to talk. So there is some difference, okay, between what is congruent versus what is equal, okay. When we talk about equality, we're referring to the two things having the same measure of something. So again, this is just a re-emphasis here of what I just said. Equality involves numbers as congruence involves shapes. You don't say two numbers are congruent just as two shapes are equal. So again, okay, we never say that two numbers are congruent. Okay, we say two numbers are equal, like 2 and 2 are equal. Okay, just like we don't say two shapes are equal because we don't say that shapes are equal. We say shapes are congruent. Okay, two shapes are the same. Two triangles are congruent, therefore they are identical. Okay, we can say they have the same. We have the same area. If they have the same area, then we say they are equal in area. Okay, again, very subtle difference, but you do need to be clear on those differences. All right, let's talk about this, okay? Finding the lengths of AC, BC, CA, and CB, and these points are actually plotted on a number line. Pause the video to see if you can figure out what this is. And welcome back. We're trying to figure out what AC is. So if I look at this, I notice that AC is this length right here, okay? And I'm trying to figure out what that is. So if you notice right now, okay, the points on this number line, they are not to scale. If they're not to scale, then that means I do not count the grid, okay, to figure out what the distance, what that length is. So to find out what AC is, okay, if A is at 5 and C is at -3, and I want to find out the total length, well, what that turns into is I'm actually just 8 away from them. A and C are 8 units away from one another. This is going to be 8. I want to figure out what BC is, and if you're, oh, I'm sorry, I went a little too fast there. If you're trying to figure out what that is, okay, you can do 5 minus -3. That's a way to figure that out, for it to be 8. And if I'm trying to figure out what BC is, okay, and again, I'm trying to figure out what that total length is, okay, so I do 3 minus -3, which is going to be 6. And I'm trying to figure out what CA is. Well, wait a minute. Is CA the same as AC? You betcha. This is still going to be 8. And is BC the same as CB? Absolutely. We're just talking about length here, okay? It's not 8. We're just talking about length here. They are all the same. Lovely. Notice that I use the absolute value symbol here. Whenever we're talking about length, okay, at least from like a physical standpoint, okay, a length will always be positive and never negative, which is why I used absolute value symbols here. But you don't have to use absolute value symbols to figure out what length is, okay? You can think about it logically. All right. The next concept here is this idea of colinear, okay? So what exactly does it mean for two things to be colinear to one another? All right, so two or more points on the same line, or two line segments that are on the same line, are described as being colinear. So for instance, I can have a straight line, okay? And this straight line, I have 2 points. These 2 points are now described as being colinear. Simple enough. They're on the same line, in other words. A and B are colinear. They're on the same line. What's another example? I can also talk about ray AB and ray AC. Okay? Ray AB and ray AC are, again, collinear if they're on the same line, which I am telling you they are. So this, okay, those two rays are on the same line. Okay? So any two things, if they're on the same line, they're described as being collinear. Which brings me to the example related to collinear. Okay, so I have now points L, M, and N, and they are collinear. LM is equal to 2x minus 5, MN is equal to 3x minus 4, and LN is equal to 6. Notice, okay, that this notation here, LM, this is describing a length. The length of LM is given by this expression here, 2x minus 5. The length of MN is given by this expression, and the length of LN is given by this number. The goal now is to find out what is the length of LM and the length of MN. All right? So pause the video here if you want, if you think you know what to do, but you may continue watching. I'll give you guys a hint, okay, before you try to tackle this on your own. The idea is you do need to apply one of the postulates, okay, that was given to you in this video. All right, so there's this idea of yeah, pause the video now and welcome back. Okay, so if you thought about this a little bit on your own, this is what you should have concluded, and that is if I have LM, if I have LM plus MN, this should equal to LN, right? And this is true because of the segment addition postulate. We were told this idea in the very beginning of the video, okay? Where I said it was the bread and butter, okay, of this lesson. So what exactly is LM is equal to? That's 2x minus 5. And what is MN equal to? Well, that is 3x minus 4. I'm performing a substitution. And what exactly is ln equal to? Ln is equal to 6. So therefore, now knowing this fact, I can then combine like terms and I can solve for x. I now know, if you want to pause the video and figure it out, please do that. I can add together 2x and 3x, and that gives me 5x. I can add together -5 and -4, and that gives me -9, and this will equal to 6. I am going to add to both sides 9 and 9, and that gives me 5x is equal to 15. Thereby, dividing both sides by 5, I will end up with x is equal to 3. Now, knowing that x is equal to 3, I can finally complete what the question is asking for, which is what is LM and what is MN. Since I know LM is 2x minus 5, I know that LM will equal to 2 times 3 minus 5, which is equal to 1. And I need to know what MN is. And since MN is equal to 3x minus 4, I know that's 3 times 4. I'm sorry. It is 3 times 3 minus 4, which is equal to 5. So MN is equal to 5. And that makes sense because 1 plus 5 does give me 6, so everything works. We've completed this first problem involving collinear. Let's take a look at the next one. Alright, so now in this problem here, you're told that XWZ is equal to 107. So XWZ, let's take a look, okay? That is this XWZ. That's the overall angle. That's everything, okay? The whole angle, it's 127. Alright, so now knowing this, okay, then we got to figure out what YWV is, okay? Pause the video if you think you have an idea of what to do. Welcome back, ladies and gentlemen. So for this problem, if you think that, oh, we need to apply the angle addition postulate, you're absolutely right. So how can we go about this? Well, I recognize, okay, that right now that these two angles, okay, have the same tick marks. So if both of them have the same tick marks, then I recognize this must be true. This must be 32. So, if my goal is to figure out what YWV is, which is this guy in the middle, okay, I'm going to call that angle there A or something, right? then I know that A plus 32 plus 32 must equal to the overall angle, which is XWZ. XWZ is 127. So what exactly is A then? Well, last I checked, 32 and 32 makes 64 is equal to 127. If I subtract both sides by 64, I'll end up with A is equal to 63. So therefore, angle YWV will equal to 63 degrees. All right, moving right along now. Okay, so the problem is getting a little more intense, okay? You're given a diagram that looks a little more abstract, okay? The goal here is all the same. We need to figure out what is the unknown AF, okay? And I notice right now in this diagram, I'm going to encourage you to actually copy this diagram and to try to figure out this problem on your own, okay? So pause the video here, please, and welcome back. So if you look at this, okay, and spotted some patterns here, that is super. Notice that there is one tick mark here, which means that these lines that are in green are all going to be the same length. And I'm going to use blue now. Notice that lines with double tick marks are going to be the same length, so that means those two lines are going to be the same length. So the goal is to figure out what is AF, and AF is this overall line that's in orange, right? So what is that? So I know that AF is equal to, again, according to segment addition postulate, it's AG plus GF. And what is the length of AG? Recognizing that the two lines that are in blue, right, which is AG is 11. So I know that it's 11 plus, and GF, what is the length of GF? All the lines that are in green, okay, have the same length. So therefore, GF must have a length of 8. So therefore, AF must equal to 19. Beautiful. All right, and then moving on here, we're talking about some problems that are just a little more involved now. So I have ABCD, okay? They are all on the same line. They are all collinear. So now you're told that AB is equal to 2x plus 5, CD is equal to 3x, and that AD is equal to 80 inches. AD is equal to 80 inches. So the overall length now, this entire thing, okay, is 80 inches. So recognizing that AB is equal to 2x plus 5, I'm going to write this down. So AB is 2x plus 5. This is actually a great tactic. If you're ever given a geometry problem, you should absolutely try to redraw the diagram and then label the heck out of it, okay? So I have AB is equal to 2x plus 5, and then I have CD is equal to 3x, okay? And I know that AD is equal to 80 inches, and this entire thing is collinear. Okay, AD is equal to 80 inches. What am I trying to solve for here? I don't think I wrote down the problem. Oh, I'm sorry. I skipped ahead a little bit. Should not have seen that. My mistake. You're trying to solve for, well, I don't think I stated it, but let's try to figure out what x is, okay? And then after we figure out what x is, let's try to figure out what AB, BC, and CD is. So what is that? Well, recognizing this, okay, that if AB is equal to 2x plus 5, and I noticed that in the diagram, AB has the same number of tick marks as BC, then therefore this also must be 2x plus 5. So now knowing this fact, 2x plus 5 is AB, BC is also 2x plus 5, and CD is 3x, I can then say, oh, 2x plus 5 plus 2x plus 5 plus 3x, all three of these must equal to 80 inches. All three of these, okay, added together must equal to 80 inches. So therefore, okay, if I combine all the like terms, 2x, 2x, and 3x, that gives me 7x. 5 and 5 gives me 10. Therefore, 7x plus 10 will equal to 80. If I subtract both sides by 10, I end up with 7x is equal to 70. Divide both sides by 7, x will equal 10. Now that I've figured out what x is, I finally need to go back and figure out what AB is. Since AB is equal to 2x plus 5, so it's 2 times 10 plus 5. So therefore AB is 25. BC, without doing any math at all, should be the same length. That's 25. And CD, okay? CD is 3x, so therefore that is 30, because it's 3 times 10. So these are all the lengths of AB, BC, and CD. And finally, last problem here. I have DAE. I have DAE. DAE, which is this angle right here, okay, is equal to x. CAD is equal to x plus 10. CAD is equal to that, x plus 10. And then I have BAC, which is this last angle over here. I have 3 different angles, okay, which I'm going to label now as x. Whoops. Which I'm going to label as x. And then x plus 10. And then 90. Okay? So if I add all these 3 up, I'm sorry, not 90. This should be 2x. This should be 2x. So if I add all 3 of these up, okay, this should give me angle BAE. So x plus 10 plus 2x, that should give me 90. So if I add them all up, I'll have 3x plus 10 is equal to 90. Subtract both sides by 10. 3x is equal to 80. Divide both sides by, I'm sorry, not 3. That should be 4. Divide both sides by 4. I'll end up with x is equal to 20. The goal is to find out what all those individual angles are. So therefore, angle BAE will equal to 20. Angle CAD will equal to 30. And angle BAC will equal to 40. And therefore, if I add them all up, yes, I do indeed end up with 70. And that's it. Please complete these examples for as exercises. See you on the next video.